Day 519 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 438. Find all anagrams in a string. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given two strings S and P, return an array of all the start indices of P's anagrams in S. You may return the answer in any order. All right, y'all, so that may seem a little bit confusing, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input S equals a string C, B, A, E, B, A, B, A, C, and D, and P equals a string A, B, C. The output is an array of integers 0 and 6 representing the indices at which the start of P's anagram starts in S. So what does that mean? The explanation says the substring with the start of index 0 is CBA. So when we look at index 0, we come to index 0 and we can see that this is a start of an anagram of this. So what is an anagram, you ask? It says an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the letters exactly once. So once we come back here and take a look at our input S, you can see that the string CBA is an anagram of ABC. Why? Because it's the same letters as ABC used exactly once. They're just rearranged, right? And that's what makes it an anagram. So since this is an anagram of this, and this starts at index 0, we could add 0 to our array because this anagram starts at index 0. Similarly, we also have another anagram, right here. Right here. Where does it start? Let me see. ABC at index 6. So we have 0, 1, 2, 3, 4, 5, 6. Okay, sorry. So it starts right here. Boom. This is also an anagram of ABC. Why? Because it has all of the letters of ABC is just rearranged. And this starts at index 6. We go 0, 1, 2, 3, 4, 5, 6. We get to 6. Sorry, y'all. We get to 6. That's the start of our second anagram. And since that starts at index 6, we can add a 6 to our output array. Now, I hope that makes sense, but just in case it didn't, let's take a look at example 2. So in example 2, we have our input S equals a string AB, AB, and P equals a string AB. The output is 0, 1, and 2. As you can see, we have anagrams that start at index 0 right here. We have anagram that starts at index 1 right here. And we have anagram that starts at index 2 right here. The explanation says the substring with the start of index 0 is AB. So once again, we have an anagram right here. This is an anagram of this. So this starts at index 0. So we add 0 to the array. Then it says the substring with the start of index 1 is BA, which is an anagram of AB. So once again, we have another anagram right here. This is an anagram of this, and this anagram right here starts at index 1. So we add 1 to an array because that's where the anagram starts. Then finally, last but not least, the substring will start at index 2 is AB, which is anagram of AB again. So once again, we come to index 2, 0, 1, 2. We get to 2. It's another anagram, AB, AB. And this anagram started at index 2. So we added 2 to our array. And in the final output, we have an anagram that starts at index 0. We have an anagram that starts at index 1. And we have an anagram that starts at index 2. So we return an array with the integers 0, 1, and 2, representing the indexes where each anagram starts. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get into it. Now, first thing we want to do is we want to check to see if the pattern string is longer than the main string. Because that means there can't be any anagrams and we could just return an empty list. So we're going to say if p.count is greater than s.count, then we could just say, we could just return, open up the brackets and return a blank array. Boom. Then we need we need to create an array that will store the starting indices of all of the anagrams that we found. So our output array, we need to create that. So we could declare a variable called result. We'll say colon, square bracket integers. So it's going to be an array of integers, and we can initialize it like this with 2 square brackets, say equal 2 square brackets, or a blank array. Boom. Now we're going to build a frequency dictionary for all the characters in P. So example, if P is equal to ABA, we are going to keep track of how many times A equals. So it will be 2 A's and it will be 1 B. Or not, yeah, how many times A appears, not equals. So yeah, once again, say we have the string ABA. Say we have ABA, right? We're going to keep track. The dictionary would be like A2. It would be like B1, something like that, right? We're going to keep track of that. So to do that, of each letter in the in P. So boom. To do that, we are going to say var dict colon, open up the square bracket, character colon int. So the key is a character, the value is an integer. We're going to say equals to p.map. We're going to open up the brackets. We're going to say $0 inside of those brackets. Then we're going to come outside of those brackets. We're going to say dot reduce, open up the parentheses. We're going to say into colon, square bracket, colon, so blank dictionary. Come outside of the parentheses right there, open up some more brackets, and we are going to say dict comma value in, come underneath that, and we are going to say dict square bracket value comma default colon 0, come outside the square bracket, and we're going to say plus equals 1, just like that. Boom. Let me clean this up for y'all. Boom. Boom. Okay. Boom. So now we come underneath that, and we need to store the length of P for the slider window that we're going to use. So we're going to declare a variable called P count, and we're going to set that equal to P.count. Boom. Then we need to convert S into an array of characters for easier indexing. So we're going to say let chars colon is going to be an array of characters. Boom, come outside the square brackets, and we are going to set that equal to s.map, open up the square brackets, $0. Boom. Now we need to enumerate over every character in S so we can get its the character and the index. So we're going to say for, open up the parentheses, index comma char. Come outside the parentheses, we're going to say in chars dot enumerated, boom, put the parentheses, open up the brackets. Now we're going to decrease the count of the current character from the dictionary. If the character wasn't part of the pattern, its count becomes negative. So we're going to say dict square bracket char, comma, default, colon 0, come outside the square brackets, and we're going to say minus equals 1. Boom. And if the count reaches 0, we're going to remove it from the dictionary, and this helps keep dict empty only when all counts match. So we come underneath this, we're going to say if dict square bracket char, come outside the square bracket, equals 0, then we're going to open up the brackets, and we're going to say dict square bracket char, come outside the square brackets, we're going to set that equal to 0. Boom. Now, once the window exceeds the size of P, then we're going to remove the effect of the character that falls out of the window. So we come underneath this if right here. We're going to start another if. We're going to say if index is greater than or equal to P count. Then we're going to open up the brackets, and we're going to say let old char equal chars square bracket index minus P count. Boom. Then we're going to increment its count back as if it's no longer in the window. So we could come underneath this. We're going to say dict square bracket old char, comma, default, colon, 0. Come outside of that, we're going to say plus equals 1. Boom, then we come underneath that, and if the count returns to 0, we're going to remove it from the dictionary again. So we're going to say if dict, square bracket, old char, come outside the square bracket, equals 0, then we're going to open up the brackets and we're going to say dict, square bracket, old char, come outside the square bracket, equals nil. Boom. Now, if the dictionary is empty, that means all counts match and an anagram of P exists starting at the index, at index minus P count plus 1. So let me show you what that means. We're going to come right here and we're going to say if dict dot is empty, we're going to open up the bracket and we're going to say result dot append, open up the parentheses, and that means we found it starting at index minus P count minus 1. Boom. Oh, excuse me, not minus 1, plus 1. Boom. Now we need to return all of the starting indices that we have found, anagrams, by coming right here and we are going to say, oh, sorry, y'all. Actually, before we do that, let's copy and paste this. This should come right here outside of that if. Boom. Now to return all the starting indices that we found, anagrams, we come right here and we can say return result, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure it runs properly. Okay, okay, we got a typo. Let's get rid of this S right here and run it again. Let's run it. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, what does that say? Ooh, look at that, y'all. 28 milliseconds beats 77.78% of users. That's what I'm talking about. Not too bad at all. We could get those numbers up, but for now, those are some good numbers right there. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. Boom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.